Okay, this should do it.
It's up now, Terry.
Okay. So, okay, I want to kill it here. This should do it. All right. And we've got Jim Taylor waiting to come in. So admit. I need some of you guys that are co-hosts kind of watch participant list here. So we're up to 24. Okay. So I'm not going to be too formal about the minutes. If anybody is interested in reading those in detail, let me know. If anybody has a concern or a problem with what they've seen in the minutes up here, let us know and we'll try to address that. Okay. So would like to welcome our new members. So I'm not going to be too. Is that somebody needing to be muted? Okay. Do we have, I've seen several names that I haven't seen before. So if we have some new visitors that would like to say hi, please unmute and let's hear from you.
Yeah, this is Elaine Hendrick, and I joined a couple weeks ago.
Well, welcome, Lane.
Thank you.
Are you new to Austin?
No, I've been to Austin quite a while, but I've just now started trying to get a little bit interested in telescopes and astronomy, so that's why I joined.
Okay. Well, we're trying really hard post-COVID to start up our star parties again. May have heard we had one planned for tomorrow night that we've got to cancel, but there is another one scheduled at Pedernales on the 17th. So maybe you can come out and meet some of us then.
Well, very good. Thank you.
Mm-hmm. Anybody else?
Hi, it's Amos here.
Hi, Amos.
Hi.
Yeah.
So yeah, I joined just a couple of days ago, and I'm new to the Austin area. I moved here roughly about last year, November. So, and kind of, I don't really know much about this topic. It's just something that I sort of become interested recently and wanted to learn just literally anything about it, and just kind of to learn like our place in the universe in general.
Okay, great. Okay. So we have monthly meetings. You can see what they're like tonight, and informative speakers at all of those. We have a member services committee who is geared up to helping new members kind of come up to speed on astronomy. So we'll be offering some astronomy and astrophotography 101 type classes a little later this year as we kind of get back together and being able to get together. So stay with us and stay tuned, and we'll see if we can kind of up your knowledge there.
Okay, great.
Okay. Anybody else? Okay, so we're going to have a short business meeting here. We are lacking a vice president. The vice president schedules our speakers and meeting venues, so pretty important post. We are looking for somebody that could help out in that role. If it sounds interesting to you, let us know. Otherwise, we'll struggle along and as a group work out picking up new speakers. Just for your information, our August speaker will be Mr. Ed Wiley, Dr. Ed Wiley. He is a amateur astronomer, but he participates in the American Association for Variable Star Observers, AASVO. And that is the oldest fraternal organization of astronomers, I guess, in the country. They started back in the 1800s. A lot of the stars up in the heavens are not constant. They do vary in brightness for various reasons, and the reasons they do that can tell us a lot about the stars. So Ed will give us an introduction into what that association's mission is and the programs they have and what we can learn about observing variable stars. We have potentially a follow-up meeting from another colleague with the AASVO, who might go into more depth about a particular topic in that field, and he might be speaking in October. If we are able to get a live meeting on the University of Texas campus this fall, we're looking at bringing in Dr. Olson, who is from South Texas State University. He is, the best way to describe him would be, I think, an archaeoforensic pathologist astronomer. He basically solves mysteries in history and culture that are based on astronomy. So he goes to sites and does the simulations and figures out what the astronomical conditions were for historical events, and then kind of tries to corroborate the history with the astronomy. Some very interesting topics that he brings up, and we do hope we can get him on the agenda for this fall. If you know of anybody that would be a good speaker, just contact anybody on the executive committee. You can find us on austinastro.org website, and we'll entertain bringing in somebody that you might know about. Did Patrick join? Okay, Patrick is our treasurer, and I did get a message from Patrick. He couldn't join our EC meeting due to being on holiday for the 4th. And we talked about setting up a meeting late next week to go over budgets. So I'll be getting with the EC committee there to see if you guys can join a working session on Zoom to kind of finalize our budgets there. We need to present them to this meeting in August for a vote. So stay tuned for that. Our outreach chair, Joyce Lynch, organizes all of our outreach star parties and other outreach events. And Joyce, have you got an update for us?
I do. Finally, as Terry mentioned a little bit earlier, we get to have a public star party next week, the 17th of July at Pedernales Falls State Park. We can hope, as nice as the rain and cool temperatures have been, we can hope that it dries up by next Saturday, so we don't have a problem with that the way we're having with a problem tomorrow. So our next event after that will be at Inks Lake on July 31st. If you check the newsletter that came out today, there's a schedule of all of our public star parties at the 2 state parks for the rest of 2021. And I will be getting that on the website in the next few days.
Okay, thank you, Joyce. Our member services is concerned with the programs that we have to enrich basically our members' experiences in astronomy. We currently don't have an official head there, but we have Domingo Rochin acting as the member services chair until we find somebody that can take it permanently. Domingo, what have you got for us?
Well, first of all, to all the new members, welcome. And if you have any concerns or questions about what we do, please send me an email or a phone call or text, and I'll get with you on a one-to-one basis. There's going to be many opportunities throughout the year to engage in activities as far as members are concerned. And I'll be looking forward to meeting all of you in person. Thank you.
So you want to tell them a little bit about where we hold our member star parties?
Oh, yes. Okay. Our member star parties usually will be held at a ranch named Batwood Ranch, which is just north of Lampasas. In this facility right now, we still try to develop so they can have all the accommodations for you to be able to have a table with power and possibly Wi-Fi. We do have a small dome observatory there that is available to the members at any time. They can sign it out. It is a place you can go over there and spend the night, camp out, and stay with your equipment. It is a very dark site, not as dark as we would like it to be, but it's very, very dark. When it gets dark, you can see the Milky Way pretty clear. It is a little far away, but it is worth it. So we will be developing many, many places there so they make it comfortable for you to be there and wanting to be there and attend.
Okay, thanks, Domingo. Sean Leary is our communications chair, maintains the website and the content of a lot of the website. Is Sean on tonight?
I am.
Thank you. Go ahead.
Sure. Hi, everybody. On the website, I'm continuing to work on the AAS store. I've added a few more items to it. I encourage anybody who likes astronomy coffee cups with work by some of our really good astrophotographers to take a look at the site. There's a link to it on the website, and also I think there's an URL on the Sidereal Times. Other than that, I updated the SSL certificate for our website with a permanent cert, and I've completed the changeover for the new term for the email addresses for the EC board. And that's it for me.
Okay. So, Sean, I saw some email between you and Greg about the idea of us offering backlit photographs. Is that moving along, or we still think it's a good idea?
I think it's a great idea. I think the potential is to have some really beautiful images, backlit and framed and whatnot. It's a matter of, what size can we get, and which of the images are, would translate well to backlit. But I think Greg will be able to speak better about that than I.
Okay. Well, it's Greg's turn next for equipment chair, so take it away, Greg.
Okay, so on the backlit photos, what I can find so far is we can get either 8.5 by 11 or 11 by 17 sizes. I've been collecting materials to try to put together a prototype for both of those sizes, and we're not there yet. And there's still a few more details to work out. But it looks like they should be able to be put together relatively easily, and we're looking at either a plug-in 5-volt or a battery pack with a switch on it. I think probably the battery pack is going to be the better way to go, honestly.
Okay.
But yeah, hopefully I'll have that. Hopefully I'll have those prototypes done. Let's see. Well, actually, I'm leaving for Oregon Star Party next week, a week from today. So that probably won't be done before then. So it'll be in August before before that happens.
Okay. Let me ask you this: is there any chance of getting the large screen TV mounted in the observatory before you take off?
Boy, I would really love to see that happen. That's going to depend a lot on how Brian is feeling. I will check with him tomorrow, or yeah, I'll check with him tomorrow. Given that he just had shoulder surgery,
he's probably not going to be up for it within the next week or so. But I can help out with that if that would help you in any way.
If we can get him out there to at least direct us as to how to put the mounting up, maybe we can do the work.
Okay. So we're going to have a large screen TV at the observatory for several uses, really presentations, but I want to try it out with the electrically assisted astronomy rig that we're putting together to take snapshot photographs of quick photographs with astrophotography equipment, essentially video cameras, so that we can show those on that large screen and have it show up for a lot of people at one time. We may also experiment with a projector out there if there's a way to project without, blinding everybody else. So I want to play around with some of that before too long. So if we can get the TV mounted, that'd help a lot. Okay.
All right. I'll see if I can make that happen this weekend.
Okay. So I don't believe Dawn joined, or did she?
I have not seen her yet.
Okay,
Hey,
Dawn is on. Yep.
Right. On that note, Joyce, for the public start party, are you gonna need the projector?
No, I don't think so. No, not planning on it.
Domingo, I am going to want the projector. So if we meet out there tomorrow at any point, if you can bring it along with you. I've also got a tripod for you.
Okay, and do you need the screen for the projector?
Is it a screen we can keep, or is that your daughter's screen?
I'm gonna buy it from her and I'm gonna donate it. How about that?
All right, if you want to do that.
It's already donated, okay?
Okay.
All right, so go with it.
Also, Nathan has offered to donate a better projector. I just need to get with him and get a hold of that. But the one we've got should suffice to get started with anyway. Okay.
What time are you gonna be there?
I don't know yet, Domingo.
All right, just let me know. I'll for sure meet you there.
Okay, so Dawn is our liaison to the Astronomical League, which is kind of an umbrella organization for all of the astronomy societies in the country. And they publish a lot of observing programs and activities that clubs can engage in. We're always trying to increase our members' participation in the observing programs. Dawn has mentioned that they've come out with several new interesting ones this year, but she'll be with us hopefully next month. She can go into details there. As we get the star parties going, we want to kind of ramp up people that are trying out the observing programs. Okay. So one hanging item of business is the astrophotography classes that Jayanne was leading or trying to lead. They had an imaging class out at Bad Wolf Ranch in, I believe, mid-May. And they changed the date on it, so only about half the people were able to attend. So Jayanne has mentioned that she's planning to do another class, a follow-up class in August. I'm not sure what the date is. I mean, Domingo, I think you were mentioning you thought she was targeting a Wednesday, which would not be an ideal night.
Correct, the 4th. She wants to do it on the 4th.
Okay. We'll get with her. I don't know if anybody is on the meeting that has participated in one of the classes or is still due to participate in an imaging class. If you have any questions or concerns, let us know. We're going to try and facilitate that for you. Ultimately, it doesn't look like the class structure that she was offering is going to work out with us. So we are looking at building up capability to do some introductory astrophotography classes from our being hosted by some of our own excellent astrophotographers. And we'll have some more information on that in the future. I've already mentioned that Patrick and I will work on budgets this week. I'll be contacting everybody that oversees a particular budget, and we'll see if we can get a Zoom meeting for that later next week. I guess Domingo's kind of mentioned some of the Bad Wolf Ranch improvements. One last item is for this electronically assisted astronomy rig. We have basically all the equipment except the mount. We want to acquire the NEQ6 mount from Mark Johnson's estate sale. I've already talked to Beth about that, and she'll make us a good price on it. A new EQR 6R, I think, is going for about $1,600. We can probably get this mount for about $750 or $800. Okay. At that price point, I don't think we have anything to vote on, so I'll go ahead and get with Patrick, and we'll make a payment, and we'll acquire that mount and start using it. Okay, this brings us up to our presentations, unless anybody has some other business that they'd like to bring up and discuss. Or any questions at all about the star parties, the photography classes, how to find these locations we're talking about, anything you've got a concern about.
So I got a question on regarding for someone like me who didn't have any experience or nor equipment, like what is the best way, is it necessary to get equipment first, or is it okay to hang around for a few months until like I gain some knowledge?
No, it's no problem.
Can I answer that, Terry?
ahead,
Yeah. As member services, it's my duty to help you integrate into our group, and I'll be glad to do that. We do have a learner scope program, so I can put a scope in your hands for free, okay? And you don't have to buy equipment right now to get started. And the best way to learn and to get to know is to come to the members only start party, where you can mingle with everybody else in there, get to know the people, and then you can get to know other people's equipment, and then you can make intelligent choices. We have telescopes of various sizes and capacities and designs, so you can really try one and then try another one and stuff like that. So that's available to you. Get with me if you need a telescope. I'll get one in your hands, okay?
Okay.
And there'll be other programs throughout the year, like astrophotography courses and other practical astronomy classes that you will benefit too. So learning on these things will be participating in the start party, whether public or members only start parties, and having an equipment in your hands where I can put equipment in your hands and be there, okay?
Okay. So I'll just talk to you after the party next week, once I learn a little bit more.
Okay, okay.
Thanks.
You're welcome.
Okay, Terry, this is Ron. I understand that tomorrow night's star party has been canceled. Is that correct? Because of weather or what? The weather does look pretty iffy.
Yeah, Ron, the main item is mud on the field. So even if the rain doesn't become very heavy, or the clouds start to clear up, we can't really drive on the field right now. So Domingo's put a cancellation message together. I'll send that out after the meeting.
Oh, I understand. It's kind of hard to slog through mud. I'd like to see the place, but we can do it some other time.
Well, we have high hopes for the 17th if you want to make it out for the public party.
And I'll be in Tulsa, Oklahoma that weekend, but I may make it for the next one.
Okay. All right, Ron. Good to hear your voice there. One other thing that we have done a couple of times during the pandemic was we held some virtual star parties, basically trying to use photography equipment to do some image capturing and show those around to the people on a Zoom meeting and talk about equipment, play around with equipment, that kind of thing. So we may still continue to hold those occasionally as well, especially if we're going to have a tough time getting started with the face-to-face star party. So that's another option that we will talk about and may offer as well. Okay. So Brian usually does our What's Up in Astronomy. He is recovering from shoulder surgery. That's hard to say quickly. And can't be with us tonight. I had planned to do a little bit of virtual star hopping to show people what's up in the skies right now. But we're approaching 8 o'clock, and I think we should let our main speaker take over, and we'll just get started with that presentation. So, Peter, are you ready?
Yeah, I can go right now.
Okay, I'll stop sharing here and you can start sharing.
Do you guys see this screen well?
Yes, I do.
All right. So I'll just start then.
You might tell us, normally I would introduce you, Peter, but I'm going to ask you if you just say a few words about yourself before you get started, kind of give us some background.
Oh yeah, I do have a slide explaining like just my background and all, so
Okay.
I'll do that. But yeah. So
Great.
hi everyone. Thank you so much for taking your time to join me, and thank you to the Austin Astronomical Society for giving me this opportunity to share my work. This is my first time doing a scientific presentation to the public, let alone on Zoom, so I'm awed and honored to be here. And tonight, I'm going to take us through how to build a radio telescope on a budget and how to explore the cosmos with it. And before we begin, I just want to introduce you who I am and explain my background a little bit. My name is Peter Lee. I'm from Korea. I've been living there for 15 years, and I came to high school in St. Stephen's Episcopal School in Austin, Texas. I just graduated a few months back, and I'm soon to be an undergraduate student at University of Illinois at Urbana-Champaign as a computer engineering major. And while I can't thank everyone, I would like to thank Mr. Lanier and Mr. Mikan, who helped me throughout this whole journey. I think they're both here with us today. Hi, Mr. Lanier, and hi, Mr. Mikan. Mr. Lanier was my teacher in robotics and projects in science and technology class and taught me how to be an engineer and a tinkerer. And Mr. Mikan was my physics and astrophysics teacher who taught me that in science, there's more than just equations and mathematics, but human value and history. The two teachers impacted me to love science and to love building stuff. And I sort of learned that science is something that I wish to continue doing in college. All right, so this is a basic outline of today's talk, where I will first talk about what radio astronomy is and how it differentiates from the conventional sky gazing. Then I'm going to give you guys a quick rundown on the history of radio astronomy and important things that happened before, and important works and studies that affected my project hugely. I will then talk about my project, how I built it, the problems I had, different iterations, experiments, and the discoveries I made. And finally, I would like to end the presentation on a note that why this all matters and why you guys should build this. So what is radio astronomy? In simple terms, radio astronomy is a small category of astronomy that focuses on radio signals coming from astronomical objects rather than observing a visible light. And this radio signal is nothing different than visible light. They both are within the electromagnetic spectrum, but belong to different regions of it. We call the visible light because this small window within the electromagnetic spectrum is the only region that our eyes can perceive. Now, take a look at this diagram. This shows that lights in the radio wavelengths are visible within the Earth 100% all the time, even more so than the visible light. This opens what's called a radio window to astronomers, where researchers and astronomers get information from radio waves in a situation where visible light is interfered or blocked by our atmosphere. Also, another awesome thing about radio astronomy is that you don't have to wait for sunset to do an observation, and even more so, any weather situation. Essentially, you can run an observation for as long as 24 hours or more, which is impossible to do in optical astronomy because of the scorching sunlight. I mean, you can try, but you might have to wear glasses that are way thicker than mine after that. Now, let's go over some important things that have happened in the fields of radio astronomy. And I want you guys to really tune into this because you're gonna notice the things that I tell you guys here in the later slides. Radio astronomy is relatively a new field because radio technology really became a thing during the early 20th century because of the two world wars. And then they produced surplus radio equipment for the general mass. A funny thing is that the radio astronomy started from someone who was not really acquainted with astronomy itself. and his name is Karl Jansky. Jansky was one of the engineers working at Bell Labs, trying to identify what causes static noises during overseas communications. So he built this giant radio antennas to detect radio noises and label them. Some of them were due to thunderstorms, some of them were due to sun's radiation. But he noticed a strange hiss that moved throughout the day, and he later figured out that this strange signal was coming from our own Milky Way galaxy. Grote Reber, who was already an amateur radio operator and amateur astronomer at the time, was fascinated by Jansky's finding. So he built his own radio telescope that was 32 feet in diameter in his own backyard. With this, Reber was able to confirm Jansky's strange radio hiss from the heavens, and he expanded his study by creating the first radio star map ever in the history of astronomy. He was also responsible for discovering many astronomical objects that are radio sources, such as Cygnus A and Cassiopeia A. And as you could probably guess, radio sources are objects in the sky that emit electromagnetic radiation in the radio frequencies. Later on, the famous Dutch astronomer Jan Oort, who was famous for the Oort cloud and all, was hugely impressed by Reber's work and suggested the importance of radio astronomy in the studies of galaxies. He predicted that the radio signals are coming from hydrogen atoms that linger around the spiral arms of the Milky Way. His interest in radio astronomy allowed Dutch radio astronomy to flourish, which later verified his theories about the Milky Way's spiral arms structures, as they were able to map out the Milky Way galaxy in radio waves. Here, Ralph Alpher and George Gamow are not directly related to radio astronomy, but I'm mentioning them to explain the significance of radio astronomy in the context of cosmology, the history of the universe itself. Alpher's paper, famously known as the Alpha Beta Gamma paper, because of the authors of the paper, Alpher, Bethe, and Gamow, it was a clever pun by Gamow, argued that there had to be a big bang that produced elements like hydrogen, helium, and other heavier elements. Learning about this, physicists Jim Peebles and Robert Dicke suggested that there must be some sort of residual heat or radiation from the Big Bang that is spread out throughout the expanding universe as of this moment. And this was later named as the cosmic microwave background radiation. And this meant that if one could observe this cosmic microwave background radiation, that person is essentially providing the possible evidence for the Big Bang and the creation of the universe. And Arno Penzias and Robert Wilson were the first person to do that. They were the first people to empirically observe the cosmic microwave background with their radio telescope that was also known as a Holmdel horn antenna at Bell Labs. All right, so that's it for the brief study and history of radio astronomy. And before we start talking about my radio telescope, I want to introduce the works that I was hugely influenced by. The first is Professor James Aguirre's mini radio telescope. I saw this project online on his GitHub website before I started my project, and his radio telescope essentially influenced me to start my own project and build it in such a compact form factor like his. Then there is, excuse me for my slander in Greek name pronunciation, Mr. Apostolos Spenakis and Mizraelis Pictor telescope. Not only his Pictor telescope was a great reference to work on, but also his open source spectrometer program Virgo, which allowed me to analyze the signals coming from the radio sources from the sky, was a great time saver, as I could utilize the pre-made program for observation. And this saved me a lot of time without me reinventing the wheel. I will not be where I am with my project right now without standing on this giant's shoulders. So on to the main event. I decided to call my telescope Peter's Amazing Radio Telescope, PART for short, I got the naming idea from my physics teacher, Mr. Mike, and where he would make abbreviations for something that is more than 3 words, and other very conveniently named telescope, like the extremely large telescope and the very large telescope. Here's a schematics of parts. There are essentially 4 parts to this telescope: the dish, the LNA, and the SDR, and the Raspberry Pi. I settled with 2.4 gigahertz Wi-Fi mesh antenna to receive signals from the skies because it was easy enough to get and it was the most affordable option out there. LNA is short for the low noise amplifier, which amplifies radio signals with very little noise. I settled with the Newell-like Saubert H1 model because not only it works as an amplifier, but also works as a bandpass filter that filters the signals that is outside the region out. And then there is the SDR, which is short for software defined radio. An SDR is used to convert radio signals into digital ones so we can examine them on computers. So lastly, in my use, I chose the single board computer called Raspberry Pi due to its compact size and lower power consumption with a pretty good processing power. And aside from it being a pretty cheap computer to get. To sum it up, the antenna receives a signal, which is then amplified and filtered through the LNA, which is digitized through the SDR, and that is read and examined on a computer by an observer. I went through some iterations in my design. At first, I started with my antenna pointing right up in the zenith, which is just straight up in the sky, and all my components connected to my personal laptop. The problem with this was that I had to be there during the entire session of observation, which normally took hours and hours. Also, I had to set everything up from scratch because I did not have any set form factor that I set as a standard, I guess. And so the next iteration focused on putting everything inside a single container to remove all the hassle of setting it up all the time. I got an inexpensive weatherproof box and stored everything in there. Here's when I transitioned from a normal laptop to a compact Raspberry Pi, the single board computer. While this worked wonderfully, there were still some areas that needed an upgrade. For instance, I needed to run an extension cord from the outlet to power everything that is inside the box, which took a considerable amount of space, and it was a potential hazard during thunderstorms or significant weathers. So I needed a better form factor where no wires are dangling around and no space is wasted. Finally, this thing could only observe what is passing the zenith because of its fixed perspective. Also, it still looked like it was very chunky, not to mention the fact that I had to strap everything down with it. I had to strap everything down and tie a huge water jug so wind doesn't blow it off the porch. Now, this is a most recent iteration, and I made quite a bit of change. For starters, the computer, the SCR, and the LNA could be powered by a single Ethernet cable by using a power over Ethernet hat module that goes right on top of the Raspberry Pi. Moreover, I upgraded the SCR in a more expensive one, as a newer one's observable range of frequency was wider than the older one, opening up more frequencies to look into in the future. Lastly, the container and the dish itself were put on top of a dovetail mount, so I could simply mount a radio telescope onto a conventional mount. And this allowed me to track any object in the sky with given celestial coordinates. You see, I must say that the second iteration is more than enough if you're fine with your radio telescope only looking up in the zenith. And the inexpensive SCR does its job perfectly. For instance, it can detect the Milky Way galaxy just fine compared to the less affordable one. This is a parts list of a more affordable version of my radio telescope. For just around $250, you can build your own radio telescope. and you can knock a couple tens of dollars off if you use your own computer instead of buying a Raspberry Pi, and if you use your own tripod hanging around in your garage. And here's a parts list of more sophisticated and a less affordable version of my radio telescope. And like, again, please don't get intimidated by the price of this, because the previous one, a more affordable one right here, is more than enough. And here too, quite a bit of money can be saved if someone uses a cheaper altitude azimuth mount or a German equatorial mount with a go-to function, which means where you point stellar coordinates and it points to designated coordinates. Now, I'm going to talk about the things I was able to do with my radio telescope. Remember the whole history lesson about the mysterious radio hiss from the Milky Way galaxy? It was discovered that the radio frequency is due to the neutral hydrogen atoms within the galaxy, specifically after it goes through what is called a spin flip transition. Because I'm not a quantum physicist, I'll take this with a grain of salt, but to explain what spin flip transition is, you must look at a single hydrogen atom. And when you do, you see a proton and an electron, and each particle has a property called a spin. And the spin is essentially an angular momentum of a given particle. And this two particle spin are sometimes aligned and sometimes not. And there is a tiny bit of difference in energy between those two states. So when this hydrogen atom flips from a higher energy state to a lower energy state, the electron emits the excess energy in a form of electromagnetic radiation. And this electromagnetic wave has a specific wavelength in the radio frequency region of 21 centimeter, which is about 1.42 gigahertz in frequency. So this creates a spectral line just like the spectral line that you can see in a spectral analysis of stars and astronomical objects. This spectral line in particular is called 21 centimeter, or H1 line to be short. A signal coming from a single hydrogen atom would be too small to notice with even the finest equipment on Earth. However, because hydrogen is the most abundant element in the universe, and especially within the galaxies, because that's how stars are born, from a cluster of hydrogen atoms or clouds, and stars are fueled with hydrogen atoms too. So the accumulated signal in the galaxies or in interstellar space is very much detectable with radio telescope with a decent amount of sensitivity. And I apologize you guys for such a bad explanation for all this. So in short, a hydrogen atom in space emits radio waves so enough so us astronomers can detect easily. Okay, so enough about lecturing about quantum physics. Now take a look at this observation I made in March. The image on the left is the simulated image of the night sky at the respective time of the observation, and I use a conventional stellarium software to capture this. As you can see, the Milky Way galaxy is not on zenith. On the right is a graph that visualizes the strength of the signal along the y-axis and the frequencies of the signals on the x-axis. The red dotted vertical line shows where the 21 centimeter line signal should be. You guys are probably curious about the huge spike in the middle, but that's a false artificial signal from the amplifier itself, so it's something we can disregard of. Overall, this graph shows no significant signal whatsoever. And take a look at this image and the graph. When the Milky Way galaxy crosses the zenith, do you see the huge spike on the left side of the red dotted line? This is what Karl Jansky detected at the Bell Labs, and this is what drew Grote-Reber into radio astronomy. And this is, again, a bunch of hydrogen clouds in the Milky Way galaxy spewing out radio emissions to us. Now, pay close attention to this one. What do you guys see? There's a spike similar to the previous slide, but now it's shifted to the right side of the red dotted line. Can you guys figure out what may have caused this? It's the effects of a Doppler shift. Because Milky Way galaxy is a spiral galaxy, some parts of the galaxy are relatively moving towards us, while some parts are moving away from us. And this makes radio waves shrink and expand. So as you can see, a radio wave that moving towards us is squeezed because of its moving speed. So the frequency increases, and then the radio wave moving away from us, whose source is moving away from us, its frequency decreases because the source is moving away from us, so the frequency is stretched. So the wave is stretched and the frequency decreases, sorry. And let's go back to the graph again. Is there another thing that you guys notice in particular? As you can clearly see, there are two different spikes. The significance of this is that there are two different clouds of, this suggests that there are two different clouds of hydrogen atoms moving in two different speeds. And this suggests the spiral arm structure of the Milky Way galaxy. And this brings us back to Jan Oort's prediction about the structure of the Milky Way galaxy. To close this section, here's a time-lapse image of the observation and corresponding view of the night skies. This observation lasted about 24 to 25 hours. And the takeaway here is that we were essentially able to replicate the experiments and the discoveries previous famous astronomers made, and then we were sort of able to verify the quantum physics and the physics behind it. And now on to the second experiment. This experiment was conducted specifically to test out whether or not the German equatorial mount works well with my radio telescope. One astronomical object that I was looking for was Cygnus A. If you guys recall, it was one of the early astronomical radio sources Grote-Reber discovered in the late 30s. An interesting thing about Cygnus A is that it does not have a spectral line like the Milky Way galaxy. Instead, it spits out radio signal in a wide range of frequency. So if we do detect Cygnus A, we must find two things. One, the signal must not be identical to the signal from the control observation, meaning when it looks somewhere else, it should show something else. And secondly, the signal should not be a spectral line, just like the Milky Way observation that I showed right here. So first, I pointed my telescope down to the ground to get a control data. And as you could see, the spectrum is relatively flat with no significant signal. And then I pointed the telescope at Cygnus A, and I got this very, very strong signal. To make sure I was getting the signal from the radio galaxy itself, not from a random satellite passing by coincidence or a Wi-Fi signal of my friend's house that I was staying, I conducted multiple observations for about an hour or two straight, and I still got the same trend of signal throughout the whole period. Still, I cannot be entirely sure whether or not this is really the signal coming from Cygnus. If I had a little more time to work on this, and if I had gotten over my senioritis early, I might have done the same observation on a different day to see if I get the same or different type of signal. But I'm back in Korea now, so that was not really a possible thing to do. And I think this is where all of you astronomers, builders, and engineers can come together. I am by all means not a certified expert in astronomy and engineering. I am just a high school graduate who loves science and loves to build stuff. And that means whatever I did, you guys can do it too, and perhaps do it even better. You guys can observe Cygnus A, and if you end up with a similar radio signal as mine, hooray, you are probably the second person in Austin to detect radio signals from Cygnus A with a budget radio telescope. if you receive a different kind of signal consistently and prove that my data was wrong, then congratulations. You're most likely the first amateur radio astronomer in Austin who successfully detected Cygnus A with a hand-built radio telescope that costs under $300. Now, it's time to talk about important question. So what? Why should you build this thing? Why should you spend your precious time looking at radio waves coming from the heavens? Well, there are a few things I can say about that. First, it's always fun to just play around and make stuff. Second, it's something new where whole new categories of experiments and cool phenomena are waiting for you. For example, something that I am working on right now is graphing the galaxy rotation curve of our Milky Way galaxy that essentially supports the existence of dark matter. How cool is that? You can literally verify the existence of dark matter right out in your backyard. But another thing is that it positively affects astronomy itself. Are you guys fond of, oh, by the way, this is what dark matter is. So it essentially says that the expected visible disk is way slower than the actual speed of the galaxy rotating. So there must be more mass on the outskirts of the galaxy that allows it to spin faster. And this object or mass cannot be seen with electromagnetic signal or electromagnetic radiation. We can only infer from this galaxy rotation curve and such. So that's why we call this dark matter. So, and another thing is that it positively affects astronomy itself. So, are you guys fond of Leslie Peltier? For the folks who do not know or not really familiar with him, he is referred to as the world's greatest non-professional astronomer. And he made more than 100,000 observations of variable stars at the time of his death. His passionate astronomy motivated him, a single individual, to do this superhuman work that provided knowledge about the night skies to the public. And his book, Starlight Nights, convinced people to go outside and look at constellations, stars, and many other objects in the sky and ponder the myths, stories, and histories behind them. And I believe the same thing could happen in radio astronomy community, where each other's passion in looking into the radio window affects one another positively. Your neighbor's kid might get into astronomy after they look at your cool looking radio telescope. And who knows, you might be the first one to detect, oh, I don't know, a supermassive black hole in nearby galaxy. Or even better, you could be the first person to receive alien signals. Okay, these are just playful thoughts, but I really wish you guys had fun listening to me talk about the history of radio astronomy and my amazing radio telescope. I cannot thank you guys more for tuning in. And I apologize if I rushed or if I was too slow, if I was stuttering too much. And before we end, I would like to share a quote of everyone's favorite, Carl Sagan, where he says, somewhere something incredible is waiting to be known. And you guys could be the person who can find out this incredible thing that we don't know yet. Thank you. And if you have any questions, please feel free to reach out. And if you wish to view my presentation in your own time, scan the QR code to access this online. And if anyone wants it, I'll try to post it on the comment section also. Thank you.
Excellent.
All right, thanks, Peter. I can feel a lot of questions hanging in the air out there, so let's have them.
Does that work in bad weather?
Do you guys hear me?
Yes.
Okay, yeah, it does work in a bad weather. Actually, I've run it when it was raining a lot in Austin. I think it was before the crazy snow fiasco, But yeah, it does work on a bad weather. I
Do you
think,
get
mhm.
interference from electrical storms like thunderclouds?
I haven't experienced that yet, but I believe so because that does create radio signals. I think those are called terrestrial radio sources, like the thunderstorms or lightning strikes,
Uh-huh.
those kind of stuff. I think Mr. Mikan had a question. I think I saw him like holding his hand up.
Frank, did you have a question?
No, I don't. I just congratulating him. That did a good job.
Great job. Good job.
Daughter 1, 2, and 3 say you did a great job.
Thank
So,
you.
sounds like you might be listening from a classroom or something. Okay.
Yeah.
I just wanted to say,
The family room.
Go ahead, Bob.
I just wanted to say thank you very much, Peter. That was a great presentation. You did an excellent job. I thought it was very informative. I noticed you were focusing on the 1.4 gigahertz range. Is that because that's all you're interested in looking in, or is that a limitation of the equipment? Are there other areas that one might look at different parts of the spectrum? Thanks.
Thank you for the question, and thank you so much for complimenting the presentation. I focus on the hydrogen line spectrum just because it's probably going to be the easiest to detect. Because as I said, the hydrogen atom is the most abundant element in the universe. And there are other spectrums that other frequencies that you can look into, or other objects. For example, sun spits out all sorts of radio frequencies. I can't really tell you which one specifically, but if you just point a radio dish at the sun, you're going to get like a crazy radio signals. And also, early astronomers actually focused on, I think, 2.05 megahertz or I think it's 2.05 gigahertz range. And then the first radio map itself was captured around that area. And the picture that I showed you of Cygnus A was surveyed in the 5 gigahertz range. So there are definitely just a lot of frequencies that you can look into. But the equipment that I had, I knew that the 1.4 gigahertz range would work. That's why I focused on it. If I had more time, I would have looked into other frequencies, but to do that, I would have needed a different amplifier, the different LNA, because that LNA that I got specifically amplified the signals in the 1.4 gigahertz range. And I would need a different sort of the feed horn, the little thing that goes in front of the dish itself, where the focus light goes into. I would have built a different feed horns to capture different sort of frequencies. I hope that answered anything. I don't know if I answered it well.
Oh, it does. Thank you very much.
Excuse me, can you hear me?
Yeah, I can hear you.
Okay, hey, Peter, I just wanted to say it was an excellent presentation. Thank you. Do you have any feel for what the angular resolution of your system is?
I am not sure, but I think I calculated before, but I don't really have it in my memory. I'm sorry.
Golly, Peter, come on.
But the dish itself is a meter big. And then I don't know, I'm sorry.
That's fine. Like I said, it was an excellent presentation. Thank you.
Thank you.
So any ambitions for building an interferometer with 2 telescopes?
Sorry?
With 2 telescopes?
Oh, maybe.
Or start an array.
If I do that, like then surveying the sky and then making a picture of a Milky Way would be a lot easier with like with more than one telescope, and I don't know. Yeah, that would be really exciting. Maybe in the future.
So in general, how do you get an image from a radio telescope? Can you explain that?
So
Large radio telescope.
yeah, so the radio telescope works in a way that it only gets a signal from a single point in the sky where you point at, so you can't really just take a picture of it. But if you think of it like the camera sensors, where there's like billions of sensors in this square area, we could do the similar thing, but we could actually rotate the radio telescope a little bit, so we could survey the sky like that. And if you have more than one radio telescope, like you see in the image right here, or the very large array up in New Mexico, you are able to probably reduce the time of surveying the sky. But it is possible to survey the sky with only one radio telescope, and that's what Grote-Reber did back in the, I think, 50s.
Peter, if you were to do a survey like that, how long would you sample each, in effect, pixel, if you will?
The datas that I showed you guys in the presentation were around 10 minutes, but I tried 5 minutes and it worked pretty well. But I tend to do around 5 to 10 minutes, because if I do it shorter, the signal's not strong enough for my equipment, and the noise level would be a little bit higher because it accumulates signal, and the less time it accumulates, the more noise you will see. So each observation time would be around 5 to 10 minutes in my circumstances.
So you do a similar that we do with photography, where you take a longer exposure and you basically like stack the data to get rid of the noise and just bring out the signal. Awesome. Thank you.
Thank you. And that's why the German equatorial mount with it, like a go-to function, is kind of really important in the context of my thing, because the long exposure time is, I'm not sure about how, I'm not really a guru in astronomical photography, but it's probably a lot longer than the usual sky photography. Is that right? I don't know. Just a thought.
10 minutes would be, I mean, people do 10-minute subs all the time. From seconds to 10 minutes is probably typical. But then we accumulate hours of that data to stack it together.
So I'm wondering, going after the 21 centimeter, the H1 line is kind of a no-brainer, but I'm trying to sit here thinking, all right, what would be like the second most abundant radio emitter out there that you might go after hydrogen? Any ideas?
The Cassiopeia A is one of the emitters. And then I think Cygnus X, the supermassive black hole, I think that spits out radio signals. And also Jupiter is a great radio source in the sky. And I think you can see them all the time at this time of the year, right? So I think that would be like the natural next step to do.
So if you're observing Jupiter, you would get signals at other frequencies than the 21 centimeter band?
I would believe so, yeah.
Okay. Have you tried pointing your scope at Jupiter?
Not yet. I didn't have time to do that.
So many targets. Okay. Well, Peter, we really appreciate you coming to speak to us. It was, I think, an excellent presentation. I don't think you have to worry about your presentation skills or style at all. I think you're on your way to, you'll be doing, before you know it, really sophisticated presentations in your career. So
thank you so much.
Yeah. So yeah, thanks for sharing it with us. And if we don't have any more questions, I don't really have any more business. So Amos, you put your hand up. Did you have something?
Oh yeah, so I just want to say it was a great presentation, and while you're doing your presentation, I just kind of started Googling on a different screen, and I found this website called Picture Telescope. It's a free to use open source radioscope. It seems like if you input the parameters that you want, and it could actually do the observation for you and return the file to you via email. And I just want to ask you if that's kind of the same thing if you want to just test the water with this type of equipment.
Oh, actually, the Picture Telescope was I think I mentioned in the presentation, but yeah, it's a person that I was like hugely influenced by, and it essentially uses the same program, and that website is really, really great if you just want to just try it out, what kind of data you get. And yeah, it's an excellent website where you can just plug in the numbers and then you can use it for free, and it gives back your results like in less than a few hours. So it's a great, yeah, thank you for mentioning that. I almost forgot to talk about it. It's an excellent website. Thank you.
Yeah.
Well, there are actually quite a few public telescopes available for anybody who wants to rent time on it, or sometimes it's free time in the visual range. I didn't really even think that one might exist in the radio spectrum, so that's cool to know. How big is that Picture telescope?
I think it's 3 meters. It's just in my memory, so I'm not sure.
1.5 meter diameter, so it's 4.9 feet and 59 inches. Yeah, so it's, I don't know if that's large.
Doesn't sound very large for a radio telescope, but you know, it's yeah, small steps, I guess. Good. Okay, I'll open the floor up briefly for anybody that's got some other business that they want to go over. Otherwise, I think we can wrap the meeting up, and we'll see you guys in the August meeting. Now, one thing that you did mention with oh gosh, I'm gonna forget his name now. He did all of the observations. Oh gosh. Okay, well, I lost that thought. But anyway, I expect that. Oh, he was with the AASVO. Okay, and we're going to hear a talk about AASVO from Ed Wiley next month. So there'll be a little intersection with your presentation there, I guess. Okay, anybody?
I also want to mention that I don't know if you see my message, but the movie that you mentioned in the starting of the presentation, Contact, I thought was a great movie. I don't know if everyone saw it, but it's a really, really great movie. And I just keep wanting to watch it again and again in the last few years.
It is a great movie, and the book is by Carl Sagan. It's a good read too.
Oh yeah, I'll definitely read it. I just started to learn English roughly 6-7 years ago, and it's in the last year or two, it's kind of me starting to reading things and learning things straight in English.
Oh, Peter, that made me think. You have any thoughts or feelings about the demise of Arecibo?
Oh, it is pretty sad, but you know, I don't know. It's pretty sad, but I don't know. I guess things happen.
I guess I see it as an opportunity to build a bigger one. We got competition with the Chinese on those scopes now.
I guess so, yeah.
Okay, guys, I guess we'll go ahead and wrap up and look for you next month. Thanks, everybody, for coming out, and I hope you enjoyed it. Any questions? Like we did say, we are canceling this star party. We hope we can see some of you, though, at the public party out at Pedernales on the 17th, and we'll just keep our fingers crossed for better weather. All right.
Okey doke.
All right, thank you. Appreciate it.
Thank you.
Bye.
All right. Good night, everybody.